All right, so welcome back. Today in this video, we're going to be doing some more Civil FE exam review in the mechanics of materials sections. And we're going to be focusing specifically on combined stresses, principal stresses, and Mohr's circle. I actually do like Mohr's circle. It's probably on the easier side of things to me. It's because, I don't know, it seems like everything's plug and chug, very simple, straightforward. So I may throw some different things at you, but pretty much this is not a bad section. So let's go ahead and look at some of the practice problems that I have for you. All right, so number 1 says find the principal stresses for a stress element with normal stresses of 90 megapascals in the X and 50 megapascals in the Y. Use 10 megapascals for shear stress. All right, so what information are we given? We're given the normal stresses. We're also given the shear stress. Okay. Now, what are we trying to find? The principal stresses. All right, let's search, try to figure out how I can get principal stresses. Apparently, I don't know how to spell principal stress. All right. With a special case of two-dimensional stress, okay. The equation is for principal stresses reduced to this. So this is in two-dimensional. Here. Okay. So that's one way, because we got our stress in the X, our normal stress in the X, normal stress in the Y. And we have our shear stress. So we could literally solve that way. I think there's another way that I can solve it too, that I just wanted to bring up. Should be in like the Mohr circle. So the two non-zero principal stresses are C plus R, and then C minus R. So that's this principal stress A and principal stress B. So we could do it that way, but I like actually this way better. Okay. So let's knock these out and see what values we get. All right. So formulas needed. Sigma A is equal to sigma X plus our normal stress in the X, normal stress in the Y, all over 2 plus or minus. So the or sigma B. All right, so we'll just say plus is going to be the A and minus is going to be the B. So plus or minus the square root of sigma X minus sigma Y over 2 squared plus TXY squared. Okay. So what is sigma X? That's the normal stress in the X direction, which equals 90. And everything's in megapascals. Sigma Y is equal to what? 50 megapascals. And then, what is T sub X sub Y? That's going to be our shear stress. Okay. Choose a different color to start solving some of this stuff. All right, so let's solve for A to start. So of course we're going to be doing plus. Sigma A is equal to our sigma X, which is 90 megapascals, plus, what's my sigma Y? 50 all divided by 2. Okay. Plus square root sigma X 90 minus 50 divided by 2. All of that squared plus 10 squared. Right. And this square root goes over everything, right? So it doesn't just stop. All right, so for sigma A, I get 92.3 megapascals. And then we want to do B, principal stress B. And that is equal to same thing, 90 plus 50 over 2 minus square root 90 minus 50 divided by 2, all of that squared plus 10 squared. And my sigma B, I get 47.6 megapascals. All right, so A is 92.3. Okay, we get that. Then 47.6. So my answer is A. Have to be very careful making sure you're selecting the right answer, because for one of the answers, your principal stress A for this one and C, those were the same. So I had to make sure that you did both, solve for both so you could get the right answer. All right. Let's do number 2. All right. So number 2 says, given the drawing, find R using Mohr's circle. All right, so this is a Mohr circle one. So what information am I given? Well, I'm given an image. It looks like I'm given something, my TXY, which is 20 megapascals. I'm given 60 and 90 pascals as well. But I'm going to, first, so I know I'm trying to find R. So I know you may not can see on your end. Me kind of scrolling up. You still want to say what you're given, what you're trying to find. You might can see if I zoom in more. Okay. So you are given your shear stress. You're given the other two values. So and we're trying to find R, and we're using Mohr's circle to do that. All right. Principal stress is okay. So here's Mohr's circle. And it's important to note what information that they're giving you. So I see that they do give us TXY, which is 20 megapascals, or our shear stress. So that is equal to 20. What are we trying to find? We're trying to find R. R, so the formula that we need in this case is going to be R is equal to this formula right here. The square root of our sigma x minus sigma y all over 2. This looks familiar. Squared plus shear stress squared. All right, so how do I get my sigma x? And I will erase that and put that a little bit. All right, so I'm gonna just write out all the variables that I need. All right, so sigma x is equal to sigma y is equal to txy is equal to, all right, txy, we know that to be 20 megapascals. What about my sigma x? Normal force in the x direction. If we don't know, right, we're given this rectangular box and they're giving us some information with it, so we can mimic that box here with our question. So we know that sigma y pointing up is in the positive direction. That looks like on our box, sigma y is pointing down. So we know that our sigma y is a negative 60 megapascals. Negative 60. Signage is very, very important. So, all right, sigma x to the right at the top, to the left at the bottom. Or I'm sorry, that's my shear stress. So, but here, sigma x points outwards, pulls outwards. And so what does ours do? Well, ours pulls outwards the same as sigma x, so it's a positive 90 megapascals. Okay, so by mimicking, we're able to get our sigma x and sigma y, and now we have all the variables we need to solve for R. So R is equal to the square root of 90 minus Don't forget your signage. 60 megapascals. You don't really need all of our units are actually the same in this, but divide that by 2 and then we square it. So if you notice, we have a 90 minus a minus 60. So that turns it into a positive, right? So depending on that sign or signage, if you didn't put that in right, it's going to change your answer. So you want to make sure that you are mimicking the image, and the image that they show here is always positive. So if you get an image where there's an arrow pointing the opposite direction, you know that your sigma x or sigma y or shear stress is negative in that case if it's pointing in the opposite direction. Okay, so plus 20 squared. All right, so I get R to equal, for this one, 77.6 megapascals. All right. Then I get A. All right, let's look at number 3. Let's do it. Let's do it. Let's do it. All right, so this one says determine the shear stresses on a plane at a 30-degree angle to the principal stresses of 120 megapascals and 60 megapascals. Alrighty. So how do we go about getting this answer? First thing we want to do is write out our givens. They give us an angle, which is 30 degrees, angle to the principal stresses of 120 megapascals and 60 megapascals. All right, so given we have 30-degree, we have an angle to the principal stresses, and we have principal stresses. All right, what are we trying to find? We're trying to find the shear stress. All right. So, well, the first thing we need to do is find the formulas that we need, right? So, we need to know what the angle is. So, very important that you note. So, the formula that we're going to need is going to be coming from what it is they're asking for. My head is right in the Mohr's, one of the Mohr's circles. I'll move myself. All right, so we have this circle is on an X and Y coordinate plane, right? This sigma X, there's a shear stress, and for sigma Y, shear stress typically the same, and in between that there is an angle, right? So this angle is 2 times that, whatever that signal or symbol is. So how do we start? How do we get Tx of y, right? So if I'm just looking at this, and I feel like I'm struggling with this a little bit. I know my angle is 30 degrees, right? So 2 times pi. And I know that 2 inches or 2in is equal to r. So do I have what information can I use? Is there any information that I can use? So let's draw it out. My principal stress is A. $120, and my okay, this is helpful. So sigma b is 60. Okay, so if I compare that, let's see, sigma b is along my, okay, so I can get the center. So I don't know what, I'm trying to solve for shear stress. Do I even know what my sigma, or do I know what r is? I can get r. Oh, this is a tough one. This is a very tough one. Okay, so I can get my sigma x. Okay, so I think I know where to go with this one, and this is why I as I'm creating these problems, I create challenging ones and force myself to work through them. So if I am given my points along this circle, right? So this is gonna really challenge us. I have this circle. I don't know the center, but I do know that is 120 this way for sigma A. And then on the other side, is 60. Sigma B. All right. And so what is R? R is equal to the center of that, right? The centerpiece of that, according to my circle, right? So I'm going to say R is equal to 60 plus 120. Does that make sense? No, I don't think that. So it's at 60. And the distance from 60 to 120. So like this point, if I'm on an X and Y axis, right? Just like it's saying, and this point is 60, and the other end is 120, then the distance between those two is going to be 120 minus 60, and then divided by 2, and that's going to give me my radius of this. Okay. All right. Or wrong. Right or wrong? So 60 divided by 2 is equal to 30. So I know my R is going to be 30. Okay. So I know that we're looking for our, so I just found R, right, of the circle, R here. So I just plotted my principal stresses, A, B, found the distance between the two, and I know that the center of those would give me my radius of it. So I know that all along the circle, my radius is 30. So if I have 30, which is R, how do I get TX Y? Well, have my R, right? And then I also have my angle. This angle is 2 times my theta. So my shear stress is going to be happening in the Y direction, right? In the Y direction. So I see sigma Y, and then what's my TXY, or my shear stress. This is what I'm solving for, this point. This point in the Y direction. So I'm solving for this line, right? And what is that? What is that height? All right. And so if I know that my R is 30, and if I'm looking for my opposite, right? So if I have R, it's going to be R sine of theta to get me the value of the Y component, which is going to be my TXY. All right. So if I have TXY, and that equals, what's my R? 30. And then my the angle in between there is 2 sine theta. So the sine of 2 theta, all right, or 2, whatever that symbol is, that's the angle. Okay. And then when I simplify it even more, I know that it's a 30-degree angle. So TXY is equal to 30 sine of 2 times 30 degrees. And so when I get that, 2 times 30. Yes. I end up getting txy is equal to my 25.98 megapascals. All right, so I struggled with that one a whole lot. But I walked myself through the problem, and after that, that's the hardest you're gonna see. So just understanding what this circle is, how to plot it, that's probably not gonna be on your test, but they may ask you a piece of that. And so if you fully understand, then you'll be able to work your way through. But yeah, this concludes the principal stresses and Mohr's circle and all of that stuff. In the next video, we're going to be looking at elastic deformation. So thanks for being patient. Thanks for going through, and hopefully this made some sense. Feel free to leave questions, comments, shoot me messages if you have questions, and I will, make sure that I get you the solutions, resources, information that you need so that you can pass this exam. All right, I'll see you in the next video.